Get your line next week. Overlay.
The only thing I see was
Overlay. Overlay.
so I passed.
Yep. One.
What? The cell doesn't work too well. I've been on the Wi-Fi.
That's all working just fine, even in the middle of the power outage. We're supposed to get some. Okay, folks. Would folks who are just walking in please come in, and would somebody by the back door please close the doors? It is time to get started.
I can do it. Last stragglers come in. Good afternoon, everybody. As usual, no world slide. I'm not going to go through it, but lots of good information there, so pay attention to that. Brief agenda. We're going to look at some of the in-situ OEM and proof of transit, where we're at with that, get some updates. We've got a section on looking at the applicability of segment routing to service chaining. Some congestion control work that's being done, some more stuff on the overlay OEMs. Name-based service function forwarding, and then some multi-domain SFC with Alto. More detailed agenda here, I'm not going to go through that. In terms of working group progress, since IETF 100, we've got the new RFC, which is operating the network service header with next protocol none. That's been published. We've adopted the proof of transit document, which we'll hear an update on shortly. And also the hierarchical SFC document as well was approved by the IESG for publication as an RFC. We still have a lot of work to do in certain areas. I think the main ones from the chair's perspective are some more work on the TLVs. We've had a lot of feedback in terms of operators would like to see some more use case kind of information on the TLVs and start to define some of those. And then we also have an action on doing some work on security.
Should that say 101 or do we not have a meeting at 101?
No, you're right. There's another typo there, Joel. It should be 101. Thank you.
And Jim, the other thing that we want to mention is that we also adopted the NSH IOM and CAP draft.
Yes. Yeah,
not only the proof of transit draft. So
yeah,
that is fairly incomplete.
Anything you want to say? Okay, so we'll dive straight into it. So Frank, please. Slides, please.
Just a moment, Frank. I get out of this.
Escape's not working, I think.
Oh, that's what I have to do.
There you are.
There you go.
Okay, so really briefly, because there's been no real document updates above and beyond the adoption of, I think I can't really use a clicker because it's a single slide.
Speak closer to the microphone.
Oh, I need to go eat it. Okay. So we adopted the IOM NSH draft after the last working group meeting. There's not really been any updates from a content perspective other than editorial changes to that particular draft. It's relatively sweet and short because, well, we're just using the next header approach, as we had the discussion in the last meeting, to go and slot in the IOM data information. And what we can do from an editorial cleanup perspective in the next step, and I think that's, let me go and ask that question one more time because we had the discussion in the last meeting, where right now we're discussing in the draft the two potential NCAP approaches for NSH. One is the next header approach, which is more hardware friendly because we're doing less TLV nesting. The other one would be to use metadata type 2, which is less efficient. And hence, well, we went for the more efficient approach within the current draft. There is a little bit of a discussion in there under the consideration section in section 4. We could go and clean that section up and just say, well, that is the agreed approach going forward, so that we are not really presenting all these options on par. It's something that we can go do. Let me know what people feel. We can also keep it the way it is right now. Any thoughts? If not immediate, just send it to the list. Other than that, well, as I said, the document is very simple. Hence, I don't expect that we need to go through a load of iterations. So if it's stable, maybe we can even go to working group last call in the next meeting. Let's get to the more fun thing, which is proof of transit. Joel, if you just fast forward to the next quote-unquote presentation, which is another single slide, because I'm just preparing the stage for Diego. So the other document, as Jim was saying earlier on, that we adopted is the SFC proof of transit draft. And again, there's been no content changes other than editorial. And as we all remember, that particular draft offers two distinct algorithmic approaches to solving the problem. One is based on Shamir secret sharing, which in the current version in the draft does not offer the option to preserve the order or check the order that a particular chain has been traversed in order. So you can check that the particular set of nodes has been visited, but not whether they have been visited in a particular order. The other approach, which uses nested encryption, has that particular capability at the expense that you're using nested encryption, which typically is more compute intense, or you require specific hardware that will do that. And we already had the discussion in the last meeting and even prior. Can't we just, rather than have two, it's always preferable to have one approach that everybody would agree with, so that we're not ending up with multiple implementations, multiple options, which is time consuming, expensive, and the likes. And well, so far we didn't really have that, but thanks to the work of Diego and team, there is a proposal now that we can go and use Shamir's secret sharing, and on top of that, have an incremental addition to allow us to use Shamir secret sharing with order preservation with some additional fairly interesting tweak that these guys came up with. And so I'm much in favor to eventually consolidate the two mechanisms into one, where we have one base algorithm, and then if you need order preservation, you can do that additional tweak that Diego is going to go talk about in a minute on top. So maybe we can just pause here, have Diego present, and then come back to that particular discussion as part of Diego's session, because that would mean we can go and clean up the document, streamline it quite a bit with these additions. Diego, why don't you just swing by?
He will.
Thank you. Okay, so since Frank's nice introduction, I think that almost everything is said. But anyway, just for you to have an idea, it's a basic proposal that we started working some time ago, and that we share with his team, then with the shares, then with all of you, just to have an idea. Basically, it is to support that the pot is ordered, which is, we believe, is a strong requirement in many cases, and this is something that is, well, has been acknowledged in the document right now. Our main concern was to make this fully compatible with the current proposal. So we are not going to force the choice of a different algorithm, or to make it much more computationally intensive, or to affect the way in which operations are considered right now by a controller entity that is distributing crit material. So we have tried, precisely because of this, to build this as an extension. So the idea is that, in principle, looking at how what we propose, we should be able to make it the use of ordered pot or unordered pot part of a level of assurance that the operator of the network wants to keep on the deployment. And well, it's something that came to our minds when thinking about that, is that, for example, if we manage to build this and to have the ordered pot, something that can be achieved as well to some extent is precisely at the station of the topology. You can verify the certain properties about the topology that the packets, since the packets are following a particular path in the network, and you can verify that, you can imply that there are some, you can attest to some extent that the topology that you intended to have is in force. So basically the method, what you have in the upper part is essentially what is right now in the pot draft. The idea is that at each link between every two nodes, we exchange the CML and the random value. And at the end, the verifier, what the verifier does is to verify that the CML that it has received is equal to the addition of the secret it has plus the random value. Basically, so at each hop, each node is adding to the at the header of the packet the combination of the combination of the results of the calculations of the polynomial coefficients it has plus the random value that was originally inserted by the ingress point. Simply, what we propose is that at the same time that you add this, the controller is distributing these polynomial coefficients to the different nodes, it provides additionally what we call a mask, and that mask is used to that mask is assigned to each link, not to each node, to each link connecting two nodes, and whenever one node is receiving a packet, it uses the ingress mask at this node to put in clear the coefficient, the polynomial value plus the random value, make the calculations, and before sending it downstream, it uses the egress mask to build the value that is sending out. That way, whatever, when at the end of the of the chain or at the end of the path, the verifier makes performs the verification, it performs exactly the same verification. There is no change on the computations that are made at each node. It can verify that if the equality holds, is because the order of the links has been the intended, because otherwise the application of the link mask would have failed, and the values of the CML at each point and the random value would have been altered. We call it a mask. Originally, we started calling it a key, but we decided to call it a mask because we wanted to remark the fact that these are a very simple computationally simple mechanism. What we are proposing in the current text we have is to use XOR. Some others, I have seen, for example, a proposal that Jack Hofstein has shared with me of an idea he was thinking about using a product. Modulus the prime. There are other potential operations. The basic idea is to have this operation computationally simple. Okay? And let me insist, is that all calculations at all nodes and the final verification are kept without any change. Well, next steps. Our idea is to incorporate this change in the POF draft. Likely as the new version of the current section 3.5 that is about other pod. And for sure that we need to update the security considerations, because if you start playing with this, you need additional thing about how you manage the masks, about which is the most adequate masking operation, while making why not XOR as a mask, for example. And ideas about, there are some discussions about rerouting that probably would need to be updated. Whatever other thing that you can think of would be extremely welcome, and whatever the enhancement. That's all. Yes.
Yeah, Frank Bruckner's one maybe just comment or addition. Diego, you always mentioned link. In essence, that doesn't necessarily need to be a link between the individual nodes. It's just the association of node n to n+1, right? Because what effectively happens is, what we didn't have so far is an association of node n and node n+1. What you're doing is, at node n, you're distorting CML so that only the node n+1 who can reverse the distortion in a symmetric operation can make sense out of CML.
Exactly. Yep.
That's exactly, so you're just providing a means to go and associate these two elements with each other. So there is no necessity of a link or anything between that. It just means, well, something
it's an
that takes the packet
it's
from
an
the
overlay link.
It's an overlay
It's a virtual link. Whatever.
It doesn't necessarily even need to be an overlay link, right? It can be multiple hops in between, because if you're only verifying
no, that's what an overlay link
one,
is.
and you have
We have a
multiple other nodes in
transport
between.
mechanism that will transport the packet from
Correct.
one SFF to another, and this binds the two ends of that together cryptographically based on the polynomial work.
Yeah, I just want to go and underline that fact. It's more generic than
fully agree. Something that we have to be careful about the wording, just to be sure that is well understood. Yeah.
Okay. Zhu?
So can we get maybe a sense in the room whether people like that approach, and whether we should go and really consider? I think there's two things that we can go do. We can first of all obviously fold that into the draft and then carry on with the two options that we have. Maybe that's the first interim step. And then on top of that, in the next meeting, decide whether we really want to go and...
We don't even have to wait for the next meeting. It's probably sensible to just put it in the draft as a first step so that we trace the breadcrumbs. But as soon as you've done that, I think we can reasonably ask the working group, can we now make this the only option for addressing that problem? Okay. We don't need to wait for November in Bangkok.
So let's swing it in, have a new revision out, and then on top of that, we can go and see whether people have a feeling towards one or the other, whether we really want to go in with one option, which would be my preference, and then maybe we have another revision and can go and settle the overall argument in the next meeting. Wonderful, thank you.
Thank you.
I wasn't sure who was presenting. Okay. There's your clicker.
Thanks. So I'm François Clade from Cisco, and I'm presenting this draft on behalf of my co-authors. And as a disclaimer, we are fully aware that this working group is chartered to work on NSH, and this is obviously not NSH. But this is still service training, and you work on service training. So we thought that it might be interesting for you to hear about this proposal, and maybe you can provide us some feedback. And also, this is not a comparison between NSH and segment routing. And I'm not going to argue about which one is the best for service training. I believe that both proposals, both architectures have their values, and they just have different use cases, in my opinion. Anyway, so the context, this draft is based on two other drafts that have been around for some time now. And these are the segment routing architecture drafts. They both mention that a segment can be associated to any type of instructions that can be topological or service-based. And while the topological instructions have been quite studied and they are well defined and well understood now, there has been little work on the service instructions. So this draft is basically about how to associate a service to a segment and how that integrates within the larger segment routing architecture. So essentially, a service segment is just another type of segment, and it inherits most of the characteristics of other segment types. It is stateless in the fabrics, meaning that all the state is actually in the packet itself. It also seamlessly integrates with other types of segment, meaning that you can combine the service segment with VPN and traffic engineering segments within the same segment list, within the same header. The service itself is also opaque to the head end and the intermediate nodes. And what does that mean? That means that what the head end and all the nodes actually see is a segment, and they only have to know how to forward the packet based on this segment. They don't need to know what is the actual service associated to the segment. That is a local knowledge of the node that instantiates the segment and the controller or the entity that computes the path and builds the seed list. These service segments can be for SRMPLS and for SRv6. For SRMPLS, the service seed is simply an MPLS label, like any other seed. And it is allocated on an MPLS router that will receive the packet, pop the label, and then either transmit the packet to the service with the label stack still on top of it, if the service is MPLS capable, or it will apply a proxy function and first remove the MPLS label stack before sending the packet to the service, and then reapply the label stack when the packet comes back.
Oh, sorry, go on.
Okay. That seed can be either taken from the global block or the local label block. That really depends on the use case. If it's taken from the global block, then the service seed can be reachable from any node in the MPLS domain. If it's local, then you need a previous segment that will steer the traffic up to the node where the local segment is instantiated. But that is the same for any other type of segments. For SRv6, it is essentially the same. The difference, of course, is that we use SRv6 seed, which are represented as IPv6 addresses instead of MPLS labels. And another difference is that the seed can also be, in some cases, instantiated on the service itself. So the service will receive the packet and do the segment routing processing, process the payload, and then forward the packet to the next segment. Then, in terms of metadata, there are several ways to carry the metadata. And it really depends what kind of metadata we're talking about. If we're talking about simply a tenant ID, then we can use the VPN segment. And that is an MPLS label or an SRv6 seed that is at the end of the segment list and identifies the tenant. If we need to do some group-based policy type of, metadata, then the segment routing header tag field would be the place to put that information. And for other types of metadata that could not be represented as a segment or would not fit in the tag field, we have in the segment routing header TLVs that we can use for carrying metadata. And in this TLV, one of the TLV is actually reusing the TLV defined for NSH. So we are not trying to kind of reinvent the wheel. In conclusion, what this graph describes is a way to bound a service to a seed, and it completely integrates within the segment routing architecture as it is defined in other drafts. It is not a new architecture that we define just for service training. And as you've noticed, it is not the SFC architecture either. But the reason why we did not try to combine the SFC and the segment routing architecture is that we believe that this will add complexity, while maybe we don't need that additional complexity and we can just do it with segment routing, at least for some use cases. So that's all for this presentation. If you have any question or feedback, that will be helpful.
Oh,
we have
somebody on mute. So Greg joined the queue.
That was just Greg joining the queue because he's presenting later. It's not a question.
Oh.
No, it's a question.
Oh, it's a question.
Please.
Okay, thank you. I raised this question in MPLS working group meeting. So by combining transport in service in MPLS encapsulation, how you see that separation of OEM, how you can distinguish between the problem in the transport and monitor the transport and monitor the service if everything is encoded as MPLS labels?
I think that we look at it differently. We look at it from a segment routing policy perspective, and when we try to do OAM, we will analyze the policy and each segment of the policy, whether that is a topological segment or a service segment.
I don't understand what you mean by analyze from policy perspective. So you know that OEM is not only a function of control plane. Many OEM functions that are residing for efficiency in a data plane. Are you saying that this notion will be propagated in a transport layer?
Hi, this is Himanshu from Sienna.
Yeah.
I just wanted to respond to Greg's, or maybe ask for a better clarification on what he's asking. So as far as I know, and you know, as far as this draft is concerned, you have a set of SID list. Some of them represents the services. So it's in terms of doing an OAM at different planes, whether it is for the transport or whether it is for the service, it is all a matter of what SID list you are including for that OAM package. If you have the service label and you have an OAM, then it goes for the service OAM. If you have only the transport SID list, then it goes for the transport OAM. I don't see specifically any issue with keeping them as a problem space.
Well, so I don't want to get too much, but the obvious issue that has been raised in the past with OAM is that you may well not want OAM packets to be sent through your services. You want to use the same service chaining, but since most applications don't really know what to do with OAM packets, because they're applications with a job to do, it is helpful to be able to tell, oh, this is an OAM packet and that's the link to the service, so I can not do that or do something different over it. And that's harder if everything's just a label. Now, that doesn't mean you can't make it work. It just means there seem to be some complexities that I think Greg is asking about.
Yeah,
Yes. Thank you, Joe.
But so how is the service OAM work if the service is only doing the service aspect of it, irrespective of whether it is done by the labels or by the NSH header, right?
Himanshu, actually, that was my question. So I'm not saying there is a problem. I'm pointing that it becomes problematic and requires very delicate attention.
Correct. Yeah. I mean, yeah, this is new topic, so something needs to be explored.
Yeah, this OAM aspect will require some work, and most probably it's more difficult with SRMPLS than SRv6. But for SRv6, what we have defined is an OAM bit in the segment routing header that allows us to identify OAM packets. And for the service segments, we would skip the service processing when we see a packet with the OAM bit set, and we would do some other processing instead, some OAM related processing instead.
One more comment, and I want to preempt what he's coming here for. So I think the point he's going to make, that train has left the station because there are any other drafts where the service, the MPLS labels are being used, or the labels themselves are used as a service identifier. There are 2 other drafts actually that talk about this, and this is the 3rd one in the service chaining. So I know your last comment was that if it is simple.
I think, and Greg's comment, Andrew Dolgan on Nokia, and Greg's comment points to the stuff. Fundamentally, we trade off here for simplicity of implementation. We trade off some of the functionality of a isolated NSH-based service implementation, and I think it would be beneficial for everybody if we start putting into the draft certain acknowledgement of those trade-offs, because there are things that we like trade-offs. There is nothing for free. So some things will not be possible, and it should be very obvious as to the reader of the draft what's possible, what's not. Yep. And those are good, in many cases, this will be a good trade-off to do. In other cases, it may not, and will make certain problems out of scope because we just admit those other limitations. And I think that's what we need to make it clear. We need to make it clear that this is a trade-off of simplicity versus flexibility of NSH, because we do tie it back to transport, which not necessarily is desired in some cases.
Yeah, there is definitely trade-offs, and we can clarify that in the draft.
Good. Thank you.
Thank you.
It's me now. Yes. Tal, since I should not be moderating something I'm co-author on, please come up. And Jim will be presenting.
Yeah, I get to present.
Let's start you at the front of the deck. No, that's the previous deck. Sorry. There we are.
Thanks, Joel. So, so I wanted to give you a brief update on a draft that that myself and some co-authors on here put together. We recognize the fact that there was some confusion over segment routing doing service chaining and NSH doing service chaining, and what we really wanted to convey was that these are complementary technologies, not competing technologies. So this is really the purpose of this draft, to show that segment routing and NSH can actually work very well together. And if you combine the two things, then hopefully you have something that's actually deployable now, as opposed to having to wait for, let's say, an SRv6 implementation that may be some time off before we could actually deploy it. I presented this in the spring working group, tough crowd, I might add. And I think we'll probably try to push this one through the spring working group, because I think the extensions that are required are kind of more related to segment routing than they are to what we do here with the NSH. So the basic intention of the draft, we described two application scenarios. There are more than two, but I think these two really highlight the applicability of where the network service header and segment routing can be deployed together to support the SFC use cases in a manner that's efficient, but also maintains the separation of the service and the transport planes, which was the original intention of the SFC architecture that we documented in RC 7665. So scenario one looks at simply using segment routing as the transport technology between SFFs, and NSH is carried beneath segment routing to do the service chaining piece. And then the second scenario looks at integrating the NSH with segment routing, whereby we actually use the segment list of, very similar to what Francois talked about in his draft, but instead of using a service SID, the SID basically says, oh, there's NSH that follows, I need to pop the segment routing stack, and I'm going to use NSH in the service plane. And I'll show you some pictures. So this is scenario one. The obvious, and the one that we documented in the draft, is the obvious one where you might have a couple of data centers where you're using the NSH encapsulation with VXLAN or whatever it may be. And you want to be able to extend the service chain between data centers across the metro. This is just an example. There are plenty of other examples, but it highlights the point. And then across the metro, maybe you want to do some kind of traffic steering to get the requirements that you need in the forwarding. So this simply is just carrying NSH underneath the transport. The transport happens to be segment routing rather than GRE or IPsec or any of the other transport encapsulations that are available to us. Pretty straightforward. I think if you read the draft, it's reasonably clear. In the draft, what we tried to do was state the benefits of these particular scenarios. In this particular one, we felt that this gives us the ability, or the network operator the ability, to take advantage of the transport independent nature of the NSH encapsulation, and also take advantage of the capabilities of segment routing for the traffic steering. The other nice thing about this is that we can avoid perhaps some of the more complex hierarchical SFC scenarios. We have an RFC, or will have an RFC on that very shortly, but it's more complex, and we can do some of the things that we describe in that draft using this mechanism in a less complex way. There's clear responsibility division between NSH and segment routing, in other words, the service plane and the transport. And it's basically applicable to any case where you've got multiple segments of a chain that are distributed across multiple domains in the network. The second scenario that we describe is the integration of the service of NSH with segment routing. As you see in this picture, basically you again carry NSH underneath segment routing, but in this case, when you get to a forwarder, the SID basically says, oh, this is a service SID, so I'm going to strip off the segment routing stack. I'm going to send the packet, the rest of the packet to the service. That packet has NSH on it, and therefore, when it comes back, I can use the path identifier in the NSH header to figure out which particular segment stack do I need to push back onto this packet. Now, the clear advantage of this is that it gets rid of all of the complexity of having to have VLANs between the services and the SFFs. The NSH path identification gives you a very nice way of removing all of that complexity. And the other, obviously, these are the stated benefits. I'm not going to bore you all with this. You can read the draft, but it just goes through what we see as some of the stated benefits of that second scenario. Encapsulation details are in the draft. I'm not going to bother going through this, but it's simply we carry NSH under the segment routing stack, whether it be SR MPLS under the label stack or whether it be SRv6 under the IPv6 encapsulation. So conclusions, the purpose of the draft is really to show that the two technologies are complementary. It's not to try and say NSH is much better than segment routing or segment routing is much better than NSH. We don't care. It's just these two things can be used in combination. If you want to use one or the other, that's fine. But if you want to combine these two things, that's fine too. The other reason for this was that the SR-based SFC has several options, each of which has pros and cons. Again, I'm not going to go into all of those. I'll be happy to have a conversation with anybody that wants to have that conversation. It's very clear on SR MPLS that there's a lot of things that it simply cannot do, especially in the metadata fields. And with SRv6, you know, the main issue there is the length of time we have to wait to actually get something that we can deploy. So in conclusion, the draft basically says that this kind of solution keeps the merits of both NSH and segment routing and therefore is attractive. So in terms of next steps, we want to get feedback on the draft, but from both Spring and SFC working groups for obvious reasons. But assuming that we get some support within the community, then we'll probably ask for adoption within the Spring working group so that these segment routing type solutions get pushed through in the so there's not kind of competing between SFC and Spring. I'd rather keep it in one place. So happy to take any questions.
Looks like we have Greg on the queue.
Oh, sorry. It was unintentional.
Oh, okay. Any other questions or comments?
Gaurav Davra, LinkedIn. I have a question on that slide which you had about the stripping of the SR header.
Which slide, sorry?
This one.
This one.
So you're defining a new behavior by stripping the SR header when you send it to the service and then it comes back. So it's on a standards track or informational?
The document's an informational.
Okay, so but there is no behavior on SFF1, right?
The only behavior is that, and this is something we'd have to discuss, I guess, through the mailing list, but the behavior required is that you need to, when you receive the NSH packet back from the service, it needs to understand for that particular path identifier, it's not going to do a lookup on the NSH and the path ID and the index to do the forwarding. It's simply going to look at that path and say, this needs to have a segment routing stack pushed onto the packet and forwarded based on the segment routing stack. So there is an implication there that we need to certainly talk through.
So in any environment, you have either some kind of a transport which is already set, whether it's MPLS or IP or something, right? I'm trying to figure out in which scenarios we would have a situation where you have NSH deployed, right? But the transport is constant.
Yeah.
And you also need segment routing for traffic engineering.
Yeah.
Which is a scenario where we need two headers, right? An SH header and a segment routing header. It's not clear to me just by.
Oh, okay. So this picture basically shows it. So in this case, where you're wanting to do segment routing between data centers, for example, to maintain some kind of SLA. In this case, what you're doing is you're carrying NSH under the segment routing because the other data center wants to continue the chain in the data center itself. So in this picture, you've got a service chain where you've got service 1 in data center 1, and then service 2 is in another data center. So in this case, you need to maintain the NSH encapsulation between those 2 points, but maybe, and frankly, this is a made up picture, but maybe you want to do some kind of traffic steering across the metro.
I mean, this picture makes sense, right? This is fine. What I'm trying to understand, because you started this presentation saying there are scenarios where it could be a different kind of transports.
Yes.
Right. In this situation, you have a transport which says MPLS in the data center, or maybe IP in the data center, MPLS between the data centers, and you have IP again in the data center. So
yeah.
Transports are constant. I already have a segment routing which is there, which is doing a traffic engineering with my inter-DC traffic, and within the DC, maybe in brownfield migrations, where you already have NSH, this may make sense. But in any migration where you're bringing in traffic engineering, we're bringing in new service chaining.
Yeah.
It may be beneficial to just use one header then.
Yeah, and all it maybe would have been easier in this picture in the red transport if I'd have said VXLAN. That would have been the simplest way to put it. So okay. I could change that picture. So what we're really saying is in the data centers in this case where there is no segment routing at this point. That's not to say there might not be in the future. Maybe there is, maybe there isn't. Some maybe not. In this case, I don't have any segment routing capability in these data centers. They're simply VXLAN. So in this case, if I want to extend chain in between them, then this is when I would combine the two things.
Okay.
Yeah.
So okay, we should talk offline.
Yeah.
I have further questions on this. Thanks.
Yeah. Actually, Kent Leong. Actually, I think this is a good example actually of where you have different types of transport domains, right? It could be MPLS or VXLAN, IPv4, right? I mean, like I said, I think this is a hypothetical example, but this kind of justify why we're having the 2 layers being split, yeah. Right? So of course, I think this approach is very favorable to NSH and by being able to maintain that, right? So, yeah. So I think it's a good idea.
Thank you.
Wim Hendricks, Nokia, one of the co-authors also from the previous thing. I believe, yeah, so there is a need, I think, we call this a decoupled model, so where service and transport are decoupled, whereas the previous presentation is more you have service and transport coupled. I wanted to, the reason I came here is on the mic was mainly because of the standardization track, because there is some forwarding behavior on the both egress from segment routing to from between the SFF and the SF, and the other direction, which is specific to this NSH forwarding, which is similar to Andy's drafts, which he will present in a bit. And as such, we might have to do standards track.
Yeah, I agree. Yeah.
So because the prefix SIT or whatever we want to call it is going to determine certain lookups and certain forwarding behaviors between the SFF and the SF that will be specific for this use case, for this, let's say, environment. So as such, I think we might have to change from informational to standards track.
Okay. Yep.
Hey, Jim. Rajiv Asari. So there's a merit, of course, in having to have both SR and NSH coexist. But the perceived challenge would be the SFF1 as an example, which instead of having to deal with NSH table lookup independently, an SR table lookup, now we may have to interchange them. So I do an NSH lookup, I got to get an SR outgoing SID list, or vice versa. That means more state that gets created, which is a lot more intricate and related than it should be. So perhaps one thought process that you could consider to really carry the SR stack, which is incoming, in maybe the metadata, which when it comes back, SFF doesn't need to do a lookup in NSH. It just does the lookup in that metadata. Use that to do a lookup back in the SR. So from the forwarding lookup point of view, nothing really changes.
Yep. Yeah, it's another option. I mean, I should say, I mean, I'm not one of the people that buys this argument about state. I think it's a bogus argument, frankly, but that's okay.
Yeah.
So I don't see an issue with the amount of state, and if I did, I wouldn't be advocating NSH because there is state. The question is that actually a problem? I don't think so, but you know, maybe smarter minds than me think that there is, but you're right. I mean, there are various ways we could do it. This is just one way that we've, you know, chosen to document it, and the purpose, as I said, initially was to show that these two things are complementary.
If not state, but necessarily the relatively simpler approach was what we ought to be thinking.
Yeah, and there are some potential. I'm still talking with the other authors, but there are some potential things that we might add. We're still in discussion because there are some other mechanisms that you could use that have pros and drawbacks.
Of course.
So we'll put it in the draft for a next spin.
Sure. Thanks.
Yeah.
So we're going to cut the lines, the current people who are currently in the line.
Just a quick comment. I was just gonna iterate the same point which the previous gentleman was saying, that yes, there is a forwarding behavior change here, right? Especially the lookups, which has been iterated a couple of times. So if we document that, then it has to go into the standard track.
Yeah, I think so too. Yeah.
And then we should discuss, because there's other intricacies here which is not being considered, especially for large-scale MSDCs.
Yeah, and to be fair, there's a couple of details from the forwarding perspective that actually Wim and I talked about this week that we need, and we're going to actually add something to the draft for a next spin, because it's a little bit more complicated than perhaps I suggested at first, and that's okay. You know, we got to start slowly, so we'll put that in there for the next revision.
Kent Leong, I actually want to say this earlier. I forgot. Actually, I thought the other thing that wasn't mentioned here was the OAM aspect, right? Actually, in some ways, this links in very well with existing SFC OAM, right? So that was brought up earlier as far how do OAM for SR6, MPLS, for example, type of stuff, right? So I think this actually naturally fits well. So just in a good example, probably to fit in the draft as well.
Yep. Thank you.
Andrew Dolgan and Nokia. So yes, standards for sure. This picture exactly shows the advantage of NSH separated from the segment routing. So we should focus on that quite a bit. Shows flexibility that the other will not give us, but will give us simpler implementation. And OEM, it will work. So last comment, I hope we're gonna progress both of those in the same forum.
Yep.
Because it will help both solutions.
Thanks, Andrew. Okay, thank you. Oh, unless you're coming up, Andy. Yeah.
Hi, I'm Andy Malice. This is a draft that presented earlier in the week in the MPLS working group, and we expect that the work will primarily be done in the MPLS working group. I'm just presenting it here for the information of the SFC working group. I don't expect to be presenting it here again, but we will be keeping the SFC working group appraised of the progress, and we'll copy all the major stuff to both MPLS and SFC list as it comes up. So the basic intention of the draft is to define an encapsulation that's used to transport SSC packets that use the network service header from one SSF to the next SSF over an MPLS infrastructure. So the picture you see here is from RFC 7665 SSC architecture, and we've just added some color. So the red nodes are MPLS-enabled LSRs that include SFFs in them. So it shows a path from a source to a destination, from SSF to SSF as usual, with service functions, and the only thing that's interesting here is that the SFFs are all part of an MPLS infrastructure. So this is the encapsulation details in order to carry the network service header over MPLS, and it's actually very simple. In green, you see the NSH header and payload, exactly as defined by RC 8300. And then on top of that, we put a label for the SFF label, and then we have transport labels over that. And this looks very simple, very, very similar to an MPLS VPN label. And the SSF label identifies a particular SFF instance at the downstream LSR or receiving node. This allows you to have more than one SFF instance at the downstream LSR. The SSF labels are advertised by the downstream LSR to an upstream LSR, which is an SFF. So that's the sending SFF. It uses standard MPLS label advertisement in the control plane, and that control plane could include LDP or RSVP or YANG, BGP, PSAP, and I have a later slide that goes into this, but it's basically standard MPLS. And because there can be multiple transport labels above the SSF label, this works with MPLS-based segment routing as well, SRMPLS. And in particular, it works with the draft that Jim just presented as well. We expect the primary usage would be scenario 1, but there's no reason why it couldn't work with scenario 2 as well. There are some ECMP considerations that that come up whenever you send anything through an MPLS infrastructure, because ECMP forwarding through an MPLS infrastructure may or may not be desirable for a particular SSE flow, and that really is a decision to be made on a flow-by-flow basis. You know, some flows will require in-order delivery and others not, and so ECMP may be desirable for some and not for others. As we know, the NSH was carefully constructed so that the first nibble of the NSH provides protection to prevent unintended ECMP by never being equal to either 4 or 6. If ECMP is desired, MPLS does have 2 native mechanisms that are available to provide entropy. One is the entropy label, and the other is the flow-aware transport label. And the co-authors are still talking amongst ourselves as to making a recommendation between one or the other. We do not yet have one. There are also OAM considerations. Greg, if you're listening, this slide is for you. OAM at the SSC layer is handled by SSC defined mechanisms as described in 8300, and OAM may also be required at the MPLS layer. And if you need an OAM at the MPLS layer, well, we have MPLS defined OAM mechanisms as well, such as GAL. That's just one example. I've been asked to compare this draft with 2 other particular drafts. So the first of the 2 is a similarly named but extremely different draft that's already a working group draft in the MPLS working group, draft IETF MPLS SFC. So the draft I'm talking about right here for the SFC encapsulation transports SSC packets with the network service header between SSFs over an MPLS infrastructure. And it supports all SFC features, and most importantly, it supports per packet metadata because we have the NSH header. However, draft IETF MPLS SFC does not use the NSH header. Rather, it uses the MPLS label stack to logically represent the NSH for interim deployments in an MPLS infrastructure that does not support the NSH at all. So there's no NSH in packets, there's no per packet metadata. There is the possibility of doing per flow metadata, and that requires either control plane extensions or a new MPLS special purpose label that is defined in that draft. And it also encodes the SSC service path indicator and service index as labels, which I put in quotes in the label stack. And the reason I put those in quotes is that they require processing different from standard MPLS labels. I've also been asked to compare this with draft ShoeClad, which we heard 2 drafts ago. And so, as I said before, my draft transports FCC packets with the NSH between SSFs, supports both traditional label swapping and SR-MPLS. When you use label swapping, there's all the usual MPLS stuff, including state, such as the lib, in every LSR along the way. And it's really intended for SFC infrastructures where the SSC NSH is present in every packet. Draft ShoeClad, rather, is intended to support a more generalized service programming in domains. Services are supported with associated with SIDS, as we saw. That draft is somewhat more general than SFC, in that services could be more than just service functions, as we define here in this working group. It works with both SR-MPLS and SRv6. It does not support MPLS label swapping, so that's one difference there, because there's no MPLS state in the routers for that draft. And the NSH is available using a TLV, the NSH carrier TLV, if you do want to use draft ShoeClad with standard SSC defined SFs. So the next steps for this draft are to progress the 4 future study items. Right now, those are the ECMP recommendation and work on the control plane. And since I wrote this draft, we've actually had more progress on the control plane. The authors of this draft have sat down with the authors of draft IETF BEST NSH BGP control plane, and we've actually determined that there's already the mechanisms that we need in that draft to support our draft here. And we may have other control options going forward as well, but certainly the best draft for the BGP control plane is one that we've heard a lot of interest about. And we'll be working towards adoption, as I said before, in the MPLS working group. So I see at least one comment or a question.
I'm the JavaScript, right? So there's a comment from Gregory Minsky.
Yes.
It's either about slide 4 or 5. It says RFC. It says 83,000. So
8,300.
No, yeah, probably a typo, but he didn't correct. So it says that RFC 8300 does not define any OAM.
It defines an OAM bit. Okay, so that's what I'm referring to. It defines the OAM bit in the NSH header, which will then be used by the actual OAM mechanisms. So that's what I was referring to right there.
Justin, sir. So you're expecting the service label to be the bottom of stack label, right?
Yes.
So probably would be good to clarify also said that both should be signaling that this is a...
Yes. Well, actually, there are some particular possibilities just with other service labels like VPN labels where it may not be exactly at the bottom of the stack. There are, for example, if we're using ELI, there's a possibility that ELI could end up underneath it. But, you know, that's something that we have to look forward to.
In general, it would make lookup easier because you just fetch your label stack, you scan to the boss, and then you look up NSH.
Yes.
Just to put it in draft. So
absolutely.
We'll get more on OAM in 2 presentations, so we can then discuss any related issues.
Okay, any other questions or comments? Well, thank you very much.
Donald?
So I'm Donald Eastlake with Huawei. I'm going to talk about explicit congestion notification and congestion feedback using the network service header and IP fix. So the goal is to be able to collect congestion information within a service function chaining domain, long paths through that domain, without having to do that by detecting dropped packets, except in the extreme cases. and to communicate congestion information back to the classifier or the ingress so that it can take action to reduce congestion. So it's communicated downstream through use of explicit congestion notification, which is defined for IP in 3168. Typically uses 2 bits. We use the same sort of thing with those 2 bits, but bits in the network service header. And congestion communication is communicated, information is communicated back using IPFix, which is defined in RFC 7011. There's a draft that extends it for this purpose. So here's kind of a diagram of what's going on. Presumably we have an original sender and a final receiver, and somewhere along that path there's this SFC domain with ingress and egress classifier, and SFFs and SFs. This is a somewhat simplified diagram, obviously. It could have proxies, it could have other things. And what you want to do is measure congestion across that. It could be that you're measuring congestion across the entire path also, which is fine, but you might not. You might still want to be able to measure congestion within the SFC domain, even if you're not doing end-to-end congestion. So the idea is to use a couple bits in the NSH. Doesn't matter which bits they are, actually. Sort of nice if they're contiguous, but the idea is that these are marked if there is 0 clear, which is what you have currently, that indicates that there's the, well, in general, when you're doing ECN, if the bits are clear, it indicates that the transport is not ECN capable. And then markings in those bits indicate that congestion has been experienced along the path. Actually, if it's one bit indicates whether it's capable or not, the other bit can indicate whether you've run into congestion. The drafts on and the RFCs on ECN explain how to encode things in those bits. So that's downstream. Upstream IPFix, there's a draft in the TSV working group on tunnel congestion feedback. And it provides a mechanism for communication statistics about how much ECN marking and maybe drop packets and things you've encountered. And you can deduce from those statistics what congestion there is. And these statistics are cumulative, so that if there are occasional dropped packets in this upstream flow, it's not a problem. The recommended transport is SCCB, so you can have less blocking, and even if the transmission is somewhat less reliable and can drop packets. So one question, what could the classifier do that would actually improve your congestion situation? Now, this doesn't claim to be a complete list, but it can throttle traffic. Possibly the ingressor classifier knows something about the further sources, and it can send further congestion feedback messages of some sort further upstream to do something. And possibly it could use this to make some decision about how it classifies things. And of course, as soon as I say that, everybody is talking about routes flipping back and forth. I'm not talking about trying to instantaneously go for less congested routes, but rather sort of a longer term thing where perhaps you have long-lived user sessions or customer sessions, and these periodically start up and terminate. If you have a new customer session coming along, it's going to last for a while. You know, that sort of thing, it would be reasonable to take some account of how congested things currently appear to be when you figure out what paths, assuming you have, of course, redundant paths that can offer the same sets of services. One thing, there's a bunch of details about how ECN works, and in generally the way ECN works, if you have a path, you want to do ECN over that path, say between 2 SFFs or something like that. You need to know whether the end of that path can properly decapsulate and take into account any ECN marking of congestion in the outer transport header. Because if it can't, then you're basically making things worse by assuming ECN marking along that path. Just to sort of give an example here, this is talking about a path, a sort of one NSH hop, so to speak, from a SFF to an SFF or an SF. And assuming you have any nodes in the middle, which might have congestion, then if everything's supporting ECN, you basically copy the ECN bits from the NSH to the outer transport at the beginning, and you combine those bits according to the ECN rules at the end. And the lower one, if you do not have an ECN-aware decapsulation at the end, then you need to have any congestion marked by dropping. Because if you, and you don't want to mark the outer transport to indicate that it's ECN capable. Because if you do that, and then the transit node indicates congestion by ECN marking, that indication will be thrown away at your ECN non-aware decapsulator at the end. There was some comments on the list about about whether this could be done in the transport header. This draft recommends, of course, doing it in the NSH, because my feeling is if you try to do this entirely in the outer transport header, you're sort of riding on the froth above this, and you have to assume that everything along the way, including any IP or label routers or whatever, label switching routers and everything, all faithfully forwards and takes care of this ECN information, even though presumably at the boxes along the way, it logically discards the outer transport header on input and then adds a new outer transport header. And it seems like a very non-robust, fragile way to do it. On the other hand, trying to mark it in the inner payload transport header will only work if you are also doing complete end-to-end congestion control, and the original sender is marking it as ECN capable. If that's not true, then you have the other problems. So because of this, you do need to add a bit of the configuration. So when you come in and you're looking at the path and the index, figure out where to go, you need one bit to indicate whether or not that hop, that index hop, is going to be ECN capable or not. So I guess, and anyway, this all will work better if you have ECN implemented everywhere. Big surprise. You do have to have ECN at all the ingress and egress nodes, but you can incrementally deploy it in the middle. Ideally, you want ECN deployed every place where there's a bottleneck, a queue somewhere that there might be packet loss. Question?
Comment more. So with regards to upstream part, I think it would really benefit from decoupling from IPFix. We see a variety of streaming telemetry protocols rising right now. Okay. I think the solution would benefit from being decoupled from IPFix specifics and being able to kind of provide this information upstream independently of what's available.
Okay, I think that's probably reasonable. Really, the mechanisms are quite independent as long as you're collecting the congestion on the way down. Any way you can get it back to the classifier so that it can make use of that information, it should work. So,
sure. I mean, in current form, it is bound semantically to IPFix, and I think it's.
Well, it seems useful to have a standard or recommended mechanism, but other things will work.
Not everyone supports IPFix, and again, there are much better techniques to provide.
Okay, well, if there's better techniques, then that's great. I would appreciate comments on the draft.
Greg,
mailing list or personally.
Greg, you have a question?
Yes, thank you. So ECN, as I understand, provides us only indication of congestion. It doesn't quantify that. So would you think that doing the measurement and then exporting with a certain threshold the results of the measurement on path would be more informative of the condition in a network?
Well, ECN is somewhat probabilistic, and so you can determine the amount of congestion by observing the relative frequency of the different ECN congestion codes at the destination when you're measuring this.
Yeah, because we have individual draft on application of alternate marking method in SFC MSH. So that allows to measure on each node cumulative packet delay variation, packet loss, and residential time. So this metrics, and then again, you don't need to export each and every measurement. These measurements can be accumulated and exported periodically over course of either time interval or number of packets measured?
Sure. Well, this sends statistics upstream, and although this is written from the point of view of those statistics coming from the egress to the ingress, if you see what the changes in ECN across any subinterval inside, including like an SFF monitoring the ECN marking changes through a ECN-enabled service function or whatever, you can certainly get other measurements internal to the SFC domain. It seemed like the most common application would be this sort of overall consideration, but others can be supported by the same ECN mechanism.
So Stuart Bryant, so I think there's been some valid points made here. I mean, I remember Yakov Stein was always explaining to me that looking at delay variation was a really good precursor indication to congestion. And given that we've got more powerful telemetry mechanisms, we're not trying to get it all down into one bit stolen from the packet. I think it's worth looking at some of these because I think we could do better than ECN, and that will be a really positive thing to do.
Sure. I believe the hope is, at least with L4S and some of the more advanced ECN methodologies, that trying to look at the delay shouldn't be very useful because there should be very little, because it's you're doing active queue management to solve your congestion problem. So you have to allow it to be congested enough to get delays, to use delay to measure congestion.
Well, I mean, yeah, I mean, clearly, if you can stay out of congestion, then you're probably not going to measure anything. But I think we should look at taking advantage of the more sophisticated telemetry and see if it helps any more than just using the 1-bit mechanism.
Okay, well, it's 2 bits, but that's okay.
Yeah. Actually, I just want to, yeah, thank you, Stuart. It's a very good observation, and I agree that jitter delay variation indication of inconsistency in the queuing.
Tal?
Tal Mizrahi Marvel. So just to clarify, in the typical use case, do you see the congestion notification being updated by SFFs, and the reaction point is the classifier?
Yes, I think that would be a typical application.
Thanks.
Okay, thanks, Donald.
Okay.
Okay, I guess I'm up now.
Yes, go ahead.
Thank you. This draft was already presented Monday to RTG group and yesterday NVO3. So if you heard it 2 times, so I apologize for the 3rd presentation. Hope that maybe we'll have some questions this time. Next slide, please. So what was the problem? We discussed identification of OEM in different groups, and I decided to take a look and compare definition of OEM identification in new protocols. And so how can we achieve to unambiguously identify OEM command and data being present in the packet? So we have, I put 2 OEM methods in the scope. The case for the active OEM that uses specifically constructed packets, and that used for fault management and performance monitoring, which are F and P in FCAPS. It could be different methods, single-ended, dual-ended, 2-way, 1-way. But important thing is that active OEM can be used for the service activation. So it generates synthetic traffic, and it could be variated packet length, inter-packet interval to generate different patterns. A hybrid OEM being defined by RFC 7799 as a combination of active and passive methods. So the active method is that when there is some impact on the network, either as a packet or changes to the data packet. And passive is that methods that are doing observation. We have, at least I'm aware at IETF, of 3 hybrid OEM methods that are alternate marking method. It triggers measurement. In situ OEM combines triggering the measurement and collecting and transporting measurement results or network and network state information, which is a telemetry information referred to in the packet itself, and hybrid 2-step method, which is a method to collect and transport telemetry information on path in a generated follow-up packet. Which protocols are looked at? So I classify them in 2 groups. Encapsulations that support optional metadata, variable size headers. These are Geneve, SFC, and SH, GUI. And encapsulations that don't support optional metadata, and thus I can refer to them as a fixed size headers. These are BEER and VXLAN GPE. Next slide, please. In Geneve, so OBIT identifies that presence of OEM packet and gives us explanation what happens with that, but does not define what OEM packet is. In GUI, the mechanism is different. The GUI uses a CBIT to indicate whether protocol command field, interpretation of the protocol command field. So if CBIT is set, then this field creates a new namespace and intended to be used among other protocols by OEM. I want to note that if the idea is that CBIT means that this packet is punted to control plane, may not necessarily well work with the OEM methods that are implemented in a data plane, and especially in some cases with a hardware assist. Because things like BFD and performance measurement protocols, they are more efficient if they're very close to their fast path and benefit from hardware assist. But this is a side note. Next slide, please. Now, SFC and SH and OEM. So, as we already mentioned earlier, so the 8300 only defines that OBIT indicates OEM packet. OEM framework is a little bit more extensive, and it says that it indicates OEM packet, but not the function. IOM and SH extends some in regard to IOM, but again, it does not address active OEM case. Next slide. For the fixed size, we have BEER RFC 8296, and BEER took approach, I believe, very pragmatic. It uses next protocol field, and OEM protocol is recorded in IANA registry. VXLAN GPE, even though this does not support metadata, uses OEM flag bit. At the same time, it does have next protocol field. Next slide. So, in cases where we have OBIT or OEM bit and next protocol, I see that there is a issue with the dual OEM identification. Again, I couldn't find there's very strict definition of OEM packet in all these specifications. So what OEM packet is, and that is especially important for applications that allow metadata. So is it OEM commands and information in header as metadata, or OEM commands and information that immediately follow the header? RFC 8393, which specifies use of next protocol none for SFC and SH, suggested that if all bits set and the next protocol value is none, then that can be used as active OEM, which I absolutely agree with. The only problem would be is that length of metadata in NSH is limited to 512 octets, and in Geneve it's even more limited if we extend this notion of non-protocol into Geneve encapsulation. It's 128 bytes, so that will limit the usability of this approach for active OEM as a synthetic traffic generator, because we can be able only to generate packets up to that length. And again, how we identify that OEM command or information follows the header, which is the most usual case for generating OEM test packets for active OEM. Next slide, please. So for all of that, I would consider following the recommendation. The O bit indicates the presence of OEM commanded data in the metadata. And OEM commands the data that follow the header indicated through the dedicated value of the next protocol field. Okay, we can go next slide. There is some discussion of OEM in case over MPLS data plane, so that we need to identify the source ID, because if we're not using IP UDP encapsulation of OEM packet, but use it as more like ACH or non-IP encapsulation, then we need to communicate the source ID. Next slide. So it's to on-path OEM, which is whether it's alternate marking method in situ or hybrid two-step. And the next slide is the finalizing slide. So there is some work that I'll be doing with this draft to update it on the GUI, because current content is not accurate, and I appreciate Tom's comment and explanation of how GUI plans to do OEM. I welcome comments, and in terms of the life of this draft, I see it as a to generate a discussion, to be used to reflect the discussion, but not necessarily being something that we'll publish at the end, but that can be revisited. So, questions?
No one is at the mic, Greg. Okay, we're going to move on to the next presentation.
All right,
Thank you very much for making the time to do this and for doing the work in producing the draft.
Okay, take it to the list. And actually, at the meeting at RTGVG, since this is a group that kind of adopted it for time being, please include RTGVG and NVO3 lists in your questions and comments.
Name-based.
Hello, everybody. So I'm Devashish Prakasta, and I'll be presenting on behalf of the co-authors. Especially Dirk was supposed to present, and he's unable to be here today. So, this is basically in an earlier draft, which is mentioned there. A new service function called SRR was described, and it was the function was to handle dynamic chaining and at the level of named transactions. And in that function, forwarding decisions were made when a service request is received using name-based identification of service endpoints. Now, in the previous meeting, we received feedback to consider these functions as to be integrated within the SFF, or maybe an extension to SFF, rather than exposing explicit service functions. So with that, in this draft, we defined ways to integrate the SRR function into the SFF. And we wanted to extend three main SFC concepts. One is this extending the service function path to include name-based interactions. We defined something called NSFP. Then the second one is extend network locator map to include name-based next hop, which is the definition of NLM. And extend service function forwarder to act on such name-based information, and it is defined as NSFF operation. And with that, we wanted to keep it as a backward compatible to the current SFC architecture. That means no changes to the functionalities of SFC nodes and NSH protocol. So the first extension is this name-based service function path. So the realization of this name-based service function path is through the extended SFF operations is kind of illustrated in the draft using HTTP transactions, where URIs are being used to name a service function along the NSFP. And this operation is not just restricted to HTTP as the protocol or the URI. It can be extended to other identifiers as well, such as IP address can be used as a name to identify the serving node. And it basically says that any identifier can be used and are interpreted as name in this NSFP. The second extension is in the network locator map, and it's called name-based network locator map. And this map is extended with the ability to consider name relations. Again, since we use HTTP as an example, URIs are used there as well as any high-level transport protocol such as HTTP for packet forwarding. And the third extension is about the whole operation, or the name-based service function forwarder is illustrated in this picture here. So this shows how the packets that are basically handled. So for example, the first step shows that the packet comes from an classifier to NSFF1, which processes the NSH header to identify the next SF by mapping the NSH information to appropriate entry in the name-based locator map. And it identifies in the name-based locator map as identified with the name as foo.com, and then it forwards to SF1. And then the service function 1 processes that and sends it back to NSFF1 again. And then it retrieves the next up information from the same network locator map and sees that it's a foo2.com. But since the service function is not being locally available, so NSF1 consults the name resolver to determine the suitable forwarding information and forward this to the next NSFF, which is the NSFF2. So the packet from NSFF1 at NSFF2, which is processed in a very similar way, and it basically processes the NSH header to identify the next SF mapping and identifies that it's a foo2.com, which eventually identifies it's a local function and forwards it to the service function 2. So So I think those are the three extensions that are described as part of this name-based service function forwarder. So as a next step, we are again want to hear from the working group about the kind of the validity of this extension, or is this, or is it in the scope of the service function working group? We also mentioned earlier that we have implemented the first version of this solution in H2020 projects, Point and Rife, and we are working to align this solution also with this draft, which is basically putting the functionality in the service function forwarder. That's it for the presentation part.
Hello, Evangelos Halapidis, Mojo.net Networks. So just a clarification question. Is this tied anyway to ICN kind of networks? Or is it going to be used there as well?
Not really, because we are just handling it as a name-based identification of the endpoints. So we didn't think about that.
Diego Lopez, just a question when you mention is just to be sure that I have gotten you right. It's about when you mentioned that the URIs is just an example. This the resolution doesn't imply any kind of DNS resolution on the URIs if the URIs are used.
Can you? I like. Did you say is DNS being used? Is that what you're asking?
Yeah. I mean, you're using URIs or URLs as a example or references for names. I assume that from what you have said, you are not DNS is not used.
In the draft, if you see, we have mentioned the different ways to we can implement. DNS is a way, but there are some problems with DNS. So we defined another way of resolving the URIs.
So I'm not read the draft.
Yeah, in the draft we have mentioned the different ways to do that.
It's about the DNS is based on A records? I hope not.
Yeah, pardon?
The DNS resolution based in A records, in address records.
Yeah, so it's one of the way we can use the DNS resolver. Yeah, it is mentioned, described there.
Okay, I want to mention a couple of points. Oh, sorry, you were.
No. I mean, I'm a little bit concerned that probably would break the idea of having the overlay completely independent from the underlay, wouldn't it?
I'm not clearly following the question. Maybe
if you're resolving the DNS, you're using the DNS to resolve the next hop. You're not taking the decision at the service function level and not on the. It's not a matter for the classifier, so you're jumping from different positions in the underlay.
Yeah, so that is one of the problems. So that's the problem. Basically, we say the DNS is not the preferred way to do it.
I'm just going to run through a number of issues that I had asked you to address in your presentation when we discussed this that I do not see in here, so that the working group can keep those in mind in considering what they want to do with this, if anything. Having name lookups in packet fast path processing is problematic for most of the use cases SFC is interested in. The dynamics, you specifically say that the whole point of this is to be able to support things which move around where instances are created and deleted. So you need to, that means that caching is of limited applicability, and that further impacts the data plane effect. Having tunnels that require TCP setup is interesting. Having tunnels that require TCP setup per packet is very interesting. And so there's a lot of issues here with the way you've done things that make this, sure, updating the table structure so it can allow a name and allow HTTP to be specified would be easy, but that has a lot of implications on service function forwarders and on their performance and behavior. And so I think it's much more complicated than you paint.
Any other questions or comments? I got someone at Danny at the mic. You have a question. Danny at the mic. Go ahead.
Can you hear me?
Yes, we can hear you.
Okay.
Oh, I see. Sorry, I thought you had a question. Okay.
Thank you.
Apologies. Yep. Okay, go ahead, Danny.
Thank you. Hello, everybody. This is Dani Lachos Perez, and on behalf of all the listed authors, I am presenting this document. Next slide, please. So this presentation is about a new word that provides initial arguments why ALTO, application layer traffic optimization, is a meaningful protocol in the context of serving function chaining traversing different domains, and it focuses on how the ALTO protocol be used to advertise and discover abstract topology, resource, and service information from different domains, and then compute inter-domain service function path. And the overall objective of this document is to start a discussion between the service function chain and the ALTO working group, and others working group are welcome, concerning if, how, and under which condition ALTO will be useful to improve the multi-domain service function chain process. Next, please.
Danny, before you continue, I just want to make clear to everybody in the room and anybody else listening, currently multi-domain support is outside of scope for the working group, and control plane support is outside of the scope for the working group. We'll let you present because it's still, we have enough time. I'd like to see your material, but people need to be aware, while interesting, this is outside of scope.
Okay, I know. Okay. I can continue. Wait, sorry.
Huh?
I can continue or?
Yes, continue.
Okay, so sorry. So in order to offer service across all the kind of boundaries, the multi-domain approach involves two aspects: multi-domain between a single operator and multi-operator collaboration. So
Slow down. Slow down. The audio is making that, little bit of problems with the audio made that completely inaudible. Sorry, slow down.
No, it's okay. Market fragmentation results from having a different operators focused to a specific region. And the technology fragmentation represents a bottleneck internally for an operator. In addition to technology domains, there are other reasons for having different domains within an operator, such as different geographies, different performance characteristics, scalability, policy, etc. Next slide, please. So in this context, a multi-domain service function chain refers to the ability to deploy service function chains across multiple domains. And this domain's division depends on circumstances such as geolocation, technology, administration, as I mentioned in the before slide. And to do so, an inter-domain communication process between different domains is necessary in order to exchange topology, resource, and service information, and then compute inter-domain service function paths. Next slide, please. So nowadays, different standardization activities and research projects have been focusing on multi-domain network service chaining. For example, the hierarchical service function chaining processes a hierarchical service function chaining for multi-domain under the same administration entity. Another document, the hybrid hierarchical multi-domain service function chaining, describes a service function chaining crossing different domains owned by various organizations. And in the network function virtualization research group, the draft multi-domain network virtualization envisions a complete end-to-end logical network as teaching services offered by multiple domains from multiple providers. And another initiative is, for example, this EXI report that describes different NFV man architectural approach with use cases related to network services provided using multiple administrative domains. Next slide, please. In case of the research group, the research project, several architectural models are integrating NFV management and SDN control capabilities to address the challenges towards flexibility and on-demand service chaining. For example, the 5GX and the 5GX transformer projects are integrating multiple administrative domains and technologies through the collaboration between operators in the context of 5G networks. Next slide, please. So it can be seen that a dialogue between potential domains could be beneficial from more effective use of resources and services and increasing the multi-domain service function chain performance. So the ALTO protocol provides abstract network information in form of map services that can be consumed by application in order to become network aware and take optimizing decisions regarding traffic flows. Presently, for example, the ALTO working group is discussing the use of the ALTO as an information model for representing network resource and service in multi-domain scenarios. For example, the broker assistant architecture proposes a broker plane working as a coordinator between a set of top-level control planes for multi-domain orchestration in 5G networks. And the Unicore draft presents a resource orchestration framework for multi-domain geo-distributed data analytics. Both proposals resourcing Alto as an information model to support resource, service, and topology discovery across different domains. And Alto and futures Alto-based extension can be used to offer, for example, an Alto property map service to get a clear global view of other potential candidate domains, and an Alto cost map services to compute inter-domain service function paths. Next slide, please. As a motivating use case, we are using a proposed architecture in the Harvard hierarchical multi-domain service function chain document. This architecture uses a service function chain exchange platform to release inter-domain communication between top-level control planes. So in a high level, the scope of the service function chain exchange platform contains two tags, provide end-to-end visibility, information from different domains, and compute inter-domain service function paths to select service function location from multiple candidate domains. In this context, the service function chain exchange platform can take advantage of the Alto services to obtain inter-domain information to guide the selection process so that the best domain or candidate domain can be selected. Next slide, please. So the hybrid hierarchical service function chain combines distributed and centralized control plane. In our use cases scenario is based on the centralized approach. This means that multiple service function chain domains are connected in a logical service function chain exchange platform, as shown in the figure on the left. And in the figure on the right, we are including an Alto server component to provide abstract map services. Next slide, please. So here we have a specific example. Figure on the left shows a service function exchange platform connecting 3 different domains, AS1, AS2, AS3. Each domain provides different service functions. For example, AS1, service function 1, AS2, service function 2, 3, AS3, service function 3. Each high-level control plane in each domain can provide inter-domain information. From this information, the service function chain exchange platform creates a hierarchical database containing inter-domain information. This information source is used by the Alto server to create different Alto map services. For example, the property map in figure on the right includes a property value grouped by autonomous system. For example, this value contains supported network functions. However, additional properties could be considered, such as network function types, resource availability, CPU, memory, storage, etc. And an Alto server can also provide cost maps. In this case, the Alto cost map defines a patch vector as an array of autonomous systems representing the AES level topological distance for a given service function chain request. The request in this example go from service function 1 to service function 2 to service function 3. And the inter-domain service function path response contains a list of potential domains to be traversed to deliver such services. In this case, we obtain 2 different service function paths. Next slide, please. So from initial discussions and review, we identified some questions and issues that need further discussion. For example, as I was mentioned before, the current service function chain working group the scope is to one single administrative domain. Even for the hierarchical service function chain draft, the assumption is that subdomains are managed by the same administrative entity. So before going into the protocol detail regarding how the release the inter-domain service changing, the idea is to describe concrete use examples with required service function from different administrative domains and start the requirement and justification for such needs. And another point is to go over the security and privacy consideration. Next slide, please. And that's it. Basically, as next step, the request is for the working group to provide a feedback. We got a review from Mohamed Boukadir, and we will address the comments in the next version. Do you have any comments on this? That will be very appreciated, or you can do that on the mailing list. Thanks.
This is Dhruv from Huawei. Without commenting on the rest of the presentation, I just wanted to give an input that there is some work in TEAS which is called SF-aware topologies, which exposes both the topology as well as SF information via the Yang models. So you can also see, like, compare between whether the Alto extensions is giving you a better approach or using a Yang model to expose the information from domain to the exchange thing that you have on the top. Just a input for something further to analyze. Thank you.
So the idea, in order to create or the abstract maps, we need a resource, an information source. In the Alto working group, this information source can be provided from different resources and formats. It's not some specific format. I don't know if I can respond to your question, or we can discuss a little bit in more details on the mailing list. Okay.
So
yeah.
This is interesting. While our charter isn't as clear as it used to be, Jim just went and looked, the NSH was approved very specifically on single domain. So I appreciate particularly, Danny, you're raising, before we do work on multi-domain, here are the questions. I'm not sure where in the IETF to entertain those questions, but they are very good questions, and it would be interesting to see them discussed further. If people have thoughts, talk to Danny by email or send them to the list as a whole. We don't slap people for sending things that are interesting, but only on the edge of our work, to the list. We'd love to see more engagement on the list, frankly. The other thing is I can see one of the blue sheets. I don't see the other one. So wherever it is, it needs to come forward. Oh, okay, there it is. Thank you. But thank you very much, Danny. There's nobody at the microphone, that's why. That's a wrap. And with that, we have completed our agenda. So thank you very much, folks. Yeah, Eric's signing the other one as the last person.